First, Richmond, this is my YouTube channel and it's for math and science only. I want to make math and science very easy here. So, if you want to learn science and math, please, this is a very good channel for you. All that you need to do is just subscribe to my channel by hitting on the red subscription button there, and then you'll be part of the group. And you can also click on the notification button up there, and then you'll be
Well,
notified
this is
anytime.
Richmond, and in this tutorial, I will be talking about the mole concept. I will limit myself to what I call how to calculate for the relative molecular masses, and then the molecular masses of some compounds. Okay, the reason why I'm not talking about giving a lot of definitions that I want to base on the calculations and how we can solve these type of questions. Okay, and please, for you to get the best out of this, you follow the tutorial to the end, because some students are complaining that the mole concept is hard to understand. And then trust me that by the end of this tutorial, you're going to get the best of it, and then you're going to understand every aspect. All right, so we move on to straight away to as a relative molecular mass and then the molecular mass. Okay, so all that I can say here is that when we talk about relative molecular mass, what is the meaning? Okay, the relative molecular mass is the sum of the relative atomic masses of the constituent atoms in the molecule. Okay, so that's the basic definition that I can give here. So if I have, let's say, a compound here, let me take one compound so that after that we try to calculate the relative atomic masses. So let's take this compound, which is H2SO4. You know this one has been hydrogen tetraoxosulfate 6, and in my tutorial on naming of oxo acid, I've taught how we name this acid. And then if you've not learned it and you want to get more knowledge about this, just go to my channel and then search for oxo acid or name oxo acid, and then it's there. Okay, here we have hydrogen here. The number of hydrogen here is 2 atoms of hydrogen, and then we have 1 atom of sulfur here, and then 4 atoms of oxygen. All right, so when we talk about molecular formula here, I'm not deviating, right? But I'm talking about molecular formula. When we talk about the molecular formula, you're talking about what is the number of hydrogen atoms, the number of sulfur, and the number of oxygen atoms which come together to form this compound. And that's what we call a molecular formula. And it's actually different from the relative molecular mass and then the molecular mass. Okay, so at this point, when we talk about the relative molecular mass, what I'm talking about that when we are able to sum up all the relative atomic masses of the individual atoms that come together to form this compound, that's what we call the relative molecular mass. So you have atomic masses of the various atoms. So hydrogen having its atomic mass, sulfur having its relative atomic mass, and then oxygen 2 is having its relative atomic mass. So when we are able to combine all the relative atomic masses of the element, we get what we call relative molecular mass. Okay, so one thing about the relative atomic mass is that students are not asked to choose them or to keep them in their mind. They are always provided if a question is asked. So now we've all understand and we all know the definition of relative molecular masses, talking about the sum total of the individual relative atomic masses of the atom that come together to form the compound. So let's try this one. Hydrogen sulfate or tetraoxosulfate, 6 acid. And then with this, they'll provide the relative atomic masses of the various atoms. So let's say the relative atomic masses are here. So let me just keep them. Hydrogen is equal to 1. Sulfur S is equal to 32. And then oxygen is equal to 16, like this. So to find the relative molecular mass of this compound, we need to know that, okay, how many atoms of hydrogen do you have here? There are 2. So you come and write the relative molecular mass of the compound H2SO4 will be equal to this. The number of hydrogen atoms, 2, plus 1 atom of sulfur here, plus 4 atoms of oxygen. Put them together like this. Okay, so now the relative atomic mass of hydrogen is 1. So we can continue here. Okay, so have 2, and then the relative atomic mass of hydrogen is 1. Place it there, so 1. Okay, plus sulfur is 32. Put it there. Plus oxygen is 16. So 4 multiply the 16 because I have the number of atoms here, oxygen atoms here are 4. So multiply the 4 by the 16. Okay, and then so this one will give us 2 plus 32 plus 64, because 4 times 16 will give us 64. So when you put everything together, we are going to get 98. And then because this one's relative atomic mass, there's no SI unit. Okay, so let's take another example and then we see how we can solve it. We want to master it, so let's take it. Example 2. And the question is just water. So to find the relative molecular mass of water, you write it this way: relative molecular mass of water will equal to the number of hydrogen atoms here is equal to 2, so 2H here plus 1 atom of oxygen. And then we know that our relative atomic masses have been provided already. So all that we need to do is simple by putting them here. So hydrogen is just 1 plus oxygen is 16. So 2 plus 16 give us 18, like this. Okay, so let's take another example, which is copper sulfate or copper 2 sulfate. So here we have SO4 here. Okay, so to calculate for this, the relative molecular mass of this atom, all that we need to do is very simple. Let's write the relative molecular mass of copper sulfate equal to, and then one thing, copper itself is having relative atomic mass of 63. So let me can add it up here. Okay, copper. So let me just add it here, and then copper is equal to 63. Okay, so like this. So copper is having a relative atomic mass of 63. So what that you then come to do here is that, okay, The number of copper atoms here is 1, so write copper, and then plus sulfur is just 1, plus 4 atoms of oxygen. So finally, what are to do? We are to just replace the atoms here by their relative atomic masses. So you have something like this. Copper is 63, so I have 63 plus 32 because sulfur is 32 plus 4, and the oxygen is 16 here, like this. Okay, so simply let's try simplify this. 63 plus 32, and then we know 16 times this will give me 64. So let's go now. 63 plus 32 plus 64. When you put everything together, I get 159. 159, like this. And this is the relative molecular mass of copper. Okay, so let's take our last example here, and it's like this. And I know by this last example you'll be very good to go and solve any questions on relative molecular mass. And then okay, so the last example is sugar, and sugar is having the formula C12 H22 and then O11, like this. So already we know the relative atomic masses of copper, of carbon, hydrogen, and then oxygen. So all you need to do here is that we are calculating for the relative molecular mass of sugar, which is C12 H22 and then O11, like this. Okay, so we just need to introduce our relative atomic masses. So how many carbons, atomic carbons do we have here? Is 12. So I have 12 carbons plus 22 hydrogen plus 11 oxygen, like this. Okay, so the relative atomic mass of carbon is 12, so I have 12 here multiplying 12 at this point, plus 22 multiplying 1, plus 11 multiplying 16, like this. Put them together like that. And what do we have to do here? 12 times 12 gives me 144. So 144 here, plus 22, and then plus 11 times 16 will give us 176. 176, like this. So when you put everything together, I'll get 342. 342. And this is the relative molecular mass. Simple, like this. So if you have any challenge, any problem, anything that you want me to do about this tutorial, please let me know it in the comment section, so that next tutorial I'll do those correction. And then if you want me to do any tutorial on any other topic in chemistry, physics, biology, e-math, let me know. Drop it down in the comment section so that I'll prepare all of that. Thank you.